Let's go through Lico 3057. Count numbers with unique digits. For this question, it gives us integer n, return the count of all numbers with unique digits, which have of x, which have 0 greater equal to x greater equal to 0 and smaller than 10 to the power n. So for example, if n equals 0, right, then x greater equal to 0 and smaller than 10 to power 0, that is 1, right? So x have one choice, that is 0, so have count 1. And for n equals 1, so that will be 0 smaller than x smaller than 10, right? And you'll see 0, 1 to 9, they are all unique. So that was 10 cases. And intuitively, what we're thinking about is that if we choose, for example, one digit for the first for the first number, for the number we are not choose, right? Then we have one choice less, and for this one we have another choice less. So intuitively, what we're thinking about is that we use, for example, this is n equals 3. Then we have 10 multiplied by 9 multiplied by 8. But this is actually wrong. Let's look at the example 2, right? If this is correct, example 1 for n equals 2 should be 10 multiplied by 9. That is 90, but this is 91, right? We're missing number 0 actually for this. So why there is some kind of number missing is that actually the reason we are missing is that for this kind of first digits, if we choose 0, the second digits we can still choose 0, right? So for the 0 case, we um, should do it separately. So that means for the 0, how many different how many if the first element is 0, how many number of unique digits for the length n minus 1, right? So that is actually the count, this one n minus 1, right? And then we can consider for the first digit we choose from 1 to 9, that there is 9 choices. Then the second digits we can choose something different than this. So there is, for example, this we choose an I, right? So we can I able to choose 0 to I minus 1 and I plus 1 to 9, right? So there are also 9 choices. And then the for third one, then we have 8 choices because we cannot choose this I and another J here, right? So we have 8 choices. So the result will be count n plus 1 plus 9 multiplied by 9 multiplied by 8 multiplied by blah, blah, blah. There are a number to multiple here. So that is from 9 to something that is n minus 1 number to multiple, right? So if we analyze this, we can write this question in recursive way. So let's write the code. So let's say if the x condition is if x n equals 0, we just return 1, right? And we need to calculate this part return. So this is the first one is the first digit is 0, right? And we should calculate the answers. What is the answers? These answers we need that is the 9 as the first digit and multiple by 9 multiple by 8, and there are n minus 1 numbers to calculate here, right? To multiply here. So we can write For example, if v equals to 9, answers equals 9, right? For int I equals to 0, I smaller than a minus 1, I plus plus, then answers multiple by equal to v minus minus. So this will be the code. And the Python code will be very similar. Let's write a Python one as well. Let's say this is the exit condition, return 1. And we're going to have v answers equals 9, 9, for I in range I minus 1. And we'll have answers multiplied by v, and v minus equal to 1. And return this one a minus 1 plus answers. Self